What's poppin', dogs? Mr. Allen here with an absolute banger of a math problem here. Get it? Absolute. Absolute values. Hilarious math joke. All right, now everybody just left. Anyways, if you're still watching, let's get after it here. We're talking transformations in this video. Transformations from the parent function f of x equals the absolute value of x to this awful looking monstrosity here. And we're going to use those transformations to graph this thing, and we're also using some t-charts to stay organized, because with this many transformations, 1, 2, 3, 4, 5 different transformations, you can get lost in the sauce, okay? Now, the first thing here, though, is I see an issue with what's going on in here with transformations. I have to be in factored form on the inside of my function in order to properly identify a horizontal shift, because it's not going to the left one. So I'm going to put it in factored form, okay? So over here on the right-hand side, because it's going to get in the way of the graph here, I can see the future of math. All right, I know where that graph's going to be. So we're going to put it over there. -2 stays the same. Absolute value. 1/3 comes out. Now, I know you're like, wait, 1/3, it's not divisible by, one's not, what? I got to take out whatever that guy is there. No matter what it does to this, I got to take this out. Now, it's a little weird when you're factoring out a fraction, but I like to think about it as, well, I'm going to put a value here, and if I multiplied it by 1/3, I'd want it to be 1. So what would that be? Well, 3 times 1/3 is 1. So this is going to be a plus 3. Another way of mathematically thinking about that is dividing out this 1/3 from 1. Dividing by 1/3 is the same as multiplying by 3. 1 times 3 is 3. So that's what goes there, right? In any event, I'd always just double check that if I did this times that, I get this. And if I did 1/3 times 3, I get that. Checks out. We're good to go. Always double check by redistributing in your head to make sure you didn't screw anything up. This absolute value was slightly smaller than that one. Now we're pretty close. Okay. So now it's in factored form. I can identify all my transformations. I'm going to do so right over here. This negative, that negative right there is a vertical reflection. So we'll write that down. Vertical reflection, also known as a reflection over the x-axis, vertical reflection, horizontal reflections over the y-axis. So I think writing it out as vertical reflection or reflection over the x-axis is fine. But if your teacher prefers one versus the other, then do that, because I'm not necessarily your teacher. All right, next one, 2. That is a vertical stretch by a factor of 2. Then the 1/3, that is a horizontal. Flip it on the inside, horizontal stretch by 3. Then we have the x plus 3 there. We can see it's not left 1, it's left 3. So left 3 and then up 5. Okay. Now I think many of us look at this and can see that, okay, I'm going to be left 3, up 5. That's where like my vertex, left 1, 2, 3, up 5. 1, 2, 3, 4, 5. I should get a point right here, right? I should get one right here. I'm just going to put a little dot. That's our guess right now. I should have that, and it should look something like this, right? That's our general idea of what's going to go on with this function, because I know it's an absolute value, which is a v. It's had a vertical reflection, so it's opening down. General idea. Now, getting the actual points can be kind of tricky. You could pick, to the left, to the right, whatever. That's totally fine. However, I'm going to show you guys a way that actually Mr. Ernst, shout out Mr. Ernst, I shouted him out in another video, but he deserves the credit. They do this point rule thing where they deal with the parent function, and then they'll also look into, then deal with the transformations thereafter, okay? So the first thing I'm going to do is my parent function. So I'm going to do that t-chart right over here, okay? So I've got x and then my f of x, which is my absolute value of x. And let's pick some numbers. I'm just going to do -2, -1, 0, 1, and 2. That sounds fine to me. It might not work out wonderfully here, but we shall see. So -2, -1, 0, 1, and 2. Okay? And then, let's see here. My output from the absolute value would just be 2, 1, 0, 1, 2. If you're okay, like looking into the future of like, oh, if I'm going to plug in these guys, should I pick some different points? There is some strategy to it. We'll talk about that afterwards if these points worked out, if there were ones that were better, so that you can make a more educated guess before you go ahead and graph next time or pick your points next time. So now I'm going to do a rather large or a wide t-chart here because we're going to put our function rules here, our point rules here. So all my horizontal transformations are going to affect which value? My x or my y. It's going to affect my x's. So anything that's horizontal will be placed in this area. So let's see, I've got a horizontal stretch by 3. So all my x values will triple. And I'm going to go to the left 3. So if my point was at 0, I'm going to subtract 3 and get negative 3. Okay, so this is more of like the literal look to it. So 3x minus 3. Notice that we don't have like the opposite sign. It's not 1/3. It's literally what it's doing to the point. It's stretching it by 3, multiplies by 3. It is moving to the left 3. I'm going to subtract 3 from its value, okay? We're no longer thinking opposite on the inside. The y values are my verticals. So vertical reflection, that's a negative. I'm going to multiply by a negative to flip it. Vertical stretch by 2, I'm going to multiply it by 2. So negative 2y, and then any others, up 5, plus 5. And now I'm just going to do this to these values. Cool? So I plug in negative 2. 3 times negative 2 is negative 6 minus 3, negative 9. Plug in negative 1. I get negative 3 minus 3 is negative 6. Plug in 0. That's gone. Minus 3 is negative 3. Plug in 1. 3 minus 3 is 0. Plug in 2. 3 times 2 is 6. Minus 3 is 3. Cool. We started at negative 9 and went up 3 each time. It's a linear equation, actually, when you look at it that way. Right, that makes sense. I went up by 3 each time because of that guy. All right, now my y's. So here I'm going to be plugging in these values. If I plug 2 in, negative 2 times 2 is negative 4, plus 5 is 1. Plug in 1, I get negative 2 times 1 is negative 2, plus 5 is 3. Plug in 0, that's gone, just left with 5. Plug in 1, I get negative 2 plus 5 is 3. Plug in 2, negative 4 plus 5 is 1. And it doesn't make sense. Those values, they go back, right? This is centered around the vertex. That's centered around the vertex. Oh, my goodness. 1, 2, 3, up. That point is there. Look at that. Just like we thought. Cool. All right. So now let's plot the rest of the points. I've got negative 6, 1, 2, 3, 4, 5, 6, up 3. Whoop. I feel like I fell off 1, 2, 3, 4, 5, 6. There we go. Kind of scooched over. It's always tough on these things without all the grid lines. All right. And then I've got negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 1. Whoop. Then over here we have 0, 3, and then 3, 1. Look at that. Ooh. Ruler. Then I can actually get it straight, even though it looks like I didn't do a very good job there. We'll make that point fat. Boom. Then it looks like, oh yeah, we totally connected all the dots. It looks great. Let's see how we did here. This one looks a little better. That's nice. Boom. Look at that, guys. Beautiful. So, perhaps you like this way. I think for some absolute value ones, not necessary, but I think it's very helpful, especially when you get like the horizontal transformations. Those always are a little tricky. You could still just pick strategic points there, but I think with radicals especially, it's helpful to use the point rule and do this whole little thing to stay organized with your transformations. So if you like it, awesome. Use it. Let me know in the comments if you guys like it. If not, you can also let me know in the comments that you did not like it, and to each their own, right? New way that I learned. I thought it was helpful, so I figured I'd share with you guys. Hope you guys liked it. I already said that. So I'm just going to end the video. See you later.